Everyone, today we are looking at data analysis and its interpretation, mastering tools, presentation, and accuracy in research. Data analysis and interpretations are central to transforming raw data into meaningful insights that answer research questions. Regardless of your discipline, sciences, social sciences, health, or education, knowing how to use the right tools, present your findings clearly, and avoid common mistakes is essential for credible research. My name is Dr. Adetitun, and this is the Master Microbiology YouTube channel. Let me tell you a story. Many years ago, more than 10-15 years ago, when I started research, I made a presentation at a conference. And then the comment came, I did not use data analysis. I said, I told the person asking me the question, I said, I used it because the values I got were in tables. And I told him I used it. He said, I did not. We started arguing. I did not know what data analysis at that level was until I went back and I sat back and I looked at what he was saying. I did not use ANOVA. I did not use chi-square. I didn't use anything. I just took the values I got from the experiment and put it in tabulated it and presented it. And I said, I've used data analysis. That is not statistical data analysis. Therefore, this video covers three key areas: basics of SPSS, Excel or R, how to present results effectively, and common data analysis errors to avoid. Number one, basics of SPSS, Excel, or R. Each software has strengths, and your choice often depends on your research objectives, statistical needs, and comfort level. For example, SPSS also refers to a statistical package for the social sciences. It is best for beginners and social science researchers. Interface: user-friendly, point-and-click menus, no coding needed. Functions: descriptive statistics, mean median mode, frequencies and cross-tabulations, t-tests, ANOVA, regression. Those in biological sciences like myself in microbiology will use SPSS analysis of variance usually. Example use for SPSS is analyzing student performance by gender using bar charts and chi-square tests. Microsoft Excel. This is best for small data sets and quick summaries that you want to do in your research. Functions: averages, sums, counts, standard deviation. Pivot tables for total summarizations. Charts like pie chart, bar chart, line chart, scatter plots. That is what I use most of the time, the charts. The limitations of this Microsoft Excel is that it's not ideal for advanced statistics, and then risk of formula errors if not carefully handled. The number three is R programming. It is best for large data, advanced statistical analysis, and reproducible research. Its strength is that it is free and open source. It is customizable graphics using packages like machine learning. Using packages like ggplot2. Then it handles complex data, modeling, time series, machine learning. Challenge of this R is that it requires basic programming knowledge, which if you don't have, then you should not use it. Now, let's look at presentation of results, tables, charts, and interpretation. Good data presentation helps your audience understand your findings at a glance. Tables: use tables for precise values and multiple variables. Keep your table clean and avoid clutter. Include titles and label columns clearly. Mention sample size, n is equal to dash. where relevant. Example table: gender mean test score standard deviation, male 68.5 and 5.2. Female, the gender mean test score and the standard deviation. The gender mean test score for male is 68.5 and the standard deviation is 5.2. For the gender female, the mean test score is 72.3, standard deviation is 4.7. Then charts and graphs. Use visual aids to highlight strengths, trends, differences, or patterns. Bar charts for categorical comparisons. Pie charts for proportions. Line graphs for trends over time. Scatter plots to show relationships between variables. Tip on this: label axis. Label the x-axis and the y-axis. Avoid 3D effects and choose colors that are easy to interpret and are visible. Interpretation: go beyond stating the obvious. Don't just say the average is 72.3. Say female scores significantly higher on average, suggesting a possible influence of study habits or teaching methods. Relate results to your research questions and hypotheses. Now, let's quickly move on to the common errors to avoid in data in this case. One of the common errors is that even with good data and tools, small mistakes can distort your findings. Number one error is a data entry error. Instead of entering 2, you entered 4. That is going to affect the interpretation and what you're going to get. So always clean your data before analysis, e.g., missing values, duplicate entries, outliners. Use software features to validate inputs, data validation in Excel, or syntax checking in SPSS or in R. Another error is misuse of statistics. If you choose the wrong test, e.g., using Pearson correlation for ordinal data, misinterpreting p-values, statistical significance is not equal to practical importance. Not checking assumptions, e.g., normality, homogeneity of variance, then overgeneralization. Avoid making sweeping conclusions from small or non-representative samples. Be honest about the limitations of your study. Now, another problem is poor visualization. Too many variables in one chart, misleading scales, or inconsistent formatting, no legends or unclear titles. As a conclusion, we need to know that effective data analysis and presentation and interpretation turn research findings into powerful knowledge. By mastering basic tools like SPSS, Excel, or R, presenting data clearly, using tables and charts, and avoiding common mistakes, researchers can communicate their findings confidently and credibly. Remember, the clarity of your analysis reflects the strength of your research. If you do a good research, you don't analyze it well, and you don't present it well, it is rubbish research still. So, my name again is Dr. Adetitun, and you are on to Master Microbiology YouTube channel. In this video today, we have spoken and we have been talking about data analysis, which is a key point in anything that we do. So data analysis and data interpretation is what you have looked at, mastering tools, presentation, and accuracy in research. If you have any questions or comments for me, drop it in the comment section of this video and I will come there and respond to you free of charge. Now, I want you to subscribe to this channel, like this video, and share the link of the video with your family and friends. If you have data you want me to analyze for you, send it. I have a team of experts working with me. We will help you to analyze the data and then we will send it back to you and even give you the interpretation. But we are not going to do it for free. We are going to charge you a token. So if you are in for that, send the data in by asking for my phone number, which is 080-369-10-988. Send me a WhatsApp message, and then we can talk, and I will see the data, and I will tell you what you're going to pay. And once you pay, we'll get to work, and then your data is analyzed and sent back to you. I will see you in the next one. This video popping up by the side right from my channel is the next one I want you to go ahead and see now. So go ahead and watch it.